So Uwe is a Director Product Manager of Glaston, Germany. He joined the company in 2002 as a sales engineer from South and Eastern Europe. In 2015, he has been responsible for sales in BAIG and the German market. Since 2019, he's heading the product management of Glaston, Germany. And Gennadi is a Director Research and Development, Glaston, Germany. Since 2019, he's heading Research and Development at Glaston for products and architectural glass. Today, they're going to be talking about thermoplastic spaces, process requirements for optimal application. So
that's right. Thank you. Start.
Thank you very much for the introduction, and good morning, everyone, from our side, from my side, and welcome to the session Thermoplastic Spacer. So in the next 20-25 minutes, you will learn a lot about the TPS spacer, about the technology itself, about the potential of this technology, and of course about the most important process parameters which are necessary to have a very good and stable production of IG units. Okay. The presentation is structured in this agenda. We will start with a short introduction about current market trends, and then we will talk, we will have also a brief look at the history of TPS, and we'll talk about the technology itself. What is TPS? In the main chapter, we will talk about the production process and what is necessary to keep the whole process under control from the beginning, from the spacer application to the final IG unit. Then I will hand over to my colleague, Uwe Risle, and he will go further with the final product, the IG unit with the spacer. At the end, of course, there will be a short outlook and summary, and we will have also some minutes for your questions. Let's start. When we have a look at the current situation on the market, there are several trends which are very clear. And the first one is sustainability. Everyone is talking about sustainability. We have heard it several times here at the GPD. And I think it's clear because we all know that our resources are limited at the end. And it's understandable that there are increasing requirements in energy efficiency worldwide. In addition, we are faced with material shortage and a worldwide increasing pollution, which becomes more and more a real problem. The sustainability trend is well founded and will change many industries, including our glass industry. The second trend concerns automation. As a machine builder, we can clearly see this trend and what are the reasons for it. At first, there is the striving for increasing productivity. For every company, it's a key to increase the productivity, to growth, or just to be competitive on an international market. At the end, it's the key for profitability. In addition, there is a lack of qualified employees. Many companies are facing the challenge of finding skilled professionals, and automation can be a solution for that. And then we have benefits with automation like reduction of errors, digitalization, and so on. So the trend will go definitely further. Furthermore, we are confronted with increasing flexibility and diversity requirements. For the production of IG units, for example, it means that it should be possible to use different spacer types, different geometries, glass sizes, and spacer widths on the same line. And so the idea and the request is always to have as many opportunities as possible with the same machinery equipment. And and this invest to have nearly no change over times, during the change of, for example, in the different spacer widths. And on the other side, everyone wants to reduce also the costs for the warehousing. And in this case, for example, for different spacer widths. So you see there are sometimes conflicting requirements, and the answer for in many other industries is additional manufacturing. We will come to that later. Finally, the quality standards are getting higher. today customers are more demanding than in the past, especially in terms of energy efficiency. And of course, they expect good quality with a long durability to an acceptable price. So these are some of the trends which we can clearly see. And the question is, what does it mean for us in the glass industry? Or more specific in our context, what does it mean for the production of IG units? And here we come now to TPS, because I'm convinced that TPS has the potential to create significant improvements in all of these areas. But before we go to the details, let's have a brief look at the history of this technology. So the journey started in 1984 when the first applicator was developed by Karl Lehnhardt. At the beginning, there were a lot of restrictions. It was possible to produce only rectangles. The spacer was limited to 12 millimeter, and the joint was done manually. But the development went further, and 10 years later, the first horizontal applicator was built. The idea here was to create larger, to enable larger spacer widths, because the material itself was not strong enough at this time. And in 1995, the first full automated vertical TPS applicator was presented, and by the way, that was the beginning of a big commercial success of TPS. Now I would like to show you what is TPS today. TPS is the direct application of a butyl-based material spacer on the glass. It's like a 3D printer for the production of the spacers. And it's very easy to variate different spacer widths. It's very easy to produce different kind of shapes. Stepped units can also be manufactured without additional manual intervention. And you can see it here in this video, the process is fully automated and works without any operators. So that's TPS today. Now, let's go deeper in the production process. How does it work? The material for the TPS spacer comes from two drum pumps. There is a master and a slave drum. With this dual drum pump system, it's possible to have an entirely interruption-free production, because during the drum change, the material will be supplied from the other drum. With the opening of the nozzle, the spacer width is defined and applied directly on the glass pane. Widths between 1 and 20 millimeters can be applied, and it's not necessary to keep them in stock like with conventional spacers. By the way, all the steps for the production of the spacers are not necessary anymore. All you need is just the IG line itself with the TPS applicator. So you can imagine also the footprint for the machinery equipment is reduced to a minimum. On this slide, we compare different process steps from the beginning, from the spacer to the final IG unit. Let's start with a conventional IG production with rigid spacers. So the first step is spacer cutting and bending. Then we have the frame printing, corner assembling, desiccant filling, butyl application, spacer storage, spacer application to the glass, assembling and gas filling, and finally sealing. So we talk in total about 9 steps, which should be under control to guarantee a good quality of the final IG unit. In the middle, we have the IG production with flexible foam spacers, and you can see the amount of steps is reduced to 6, so there is an improvement. And now let's have a look on the IG production with TPS. The first step is the spacer application to the glass. Then we have the frame printing, assembling with gas filling, and finally sealing. So there are only 4 steps, not more. And now you can imagine why TPS was and is still a game changer in the production of IG units. Yeah? At the beginning, I have talked about the automation trend. And with this technology, it's very easy to reach a much higher automation level in the IG production. Of course, you can automate all the other 9 steps too, but the process stability will be a different story, of course. Okay, but what is really important? What are the main process requirements for an optimal application? At first, we need clean glass plates. That is self-evident. The environment temperature should be between 15 and 35 degrees. Relative air humidity maximum 75. The material itself is very important. It should be a certified material. In the meantime, there are different suppliers available, so you're not depending on one supplier. The temperature range for the application is between 100 and 140 degrees Celsius. For the dosing system, we strongly recommend to use a gear pump system. Then the application speed up to 30 meters per minute is possible. Spacer widths between 1 and 20 millimeters can be applied. And there are different nozzles available, 5.8 and 6.8, depending on the maximum spacer which you would like to apply. I have mentioned that the temperature is very important, and this is why there are different heating circuits in the technology. There is one for the drum pumps for a 24-hour production, a further one for the dosing system, and in addition, a further one for the nozzles. And sometimes it's necessary to adjust them to the right environment temperatures, to the right environment settings. So you should have the opportunity to do that. And besides the application itself, there is another process very important, and this is the pressing of the IG units. Yeah? Because you should know that assembling, pressing, and gas filling of rigid spacers is completely different compared to TPS. And the main reason for that are the properties of the material. On one side, softness, and on the other side, gas tightness. So during the pressing and gas filling, it's mandatory that the air can be released and the pressure can be controlled very well. Otherwise, there will be an overpressure in the unit, and the material does not adhere very well. So the final quality will be not as good as it could be. From our 30 years of experience with this technology, we can clearly say, as long as these conditions are considered, there is a very smoothly production possible with a full automated process. And I think you have seen now the benefits of this process. So now I would like to hand over to my colleague, and he will go further with the IG unit itself.
Thank you, Gennadi, for this informative information. Welcome also from my side with some more topics about TPS material. Surprisingly, we have the situation that, as Gennadi said, the market it was introduced with TPS almost 30 years ago. But in many projects, the important role for TPS is not there for architects or window manufacturers. Therefore, I like to take the opportunity to give you some more advantages of the TPS material itself. The special thing is, this is a 3-in-1 solution. Spacer, desiccant, and primary sealant in one material. Homogeneous, continuously applied spacer with the tightest possible joint. And this gives then a premium warm edge insulating glass unit without any condensation. A very important area of the spacer is the joint. There should be an overlap between the beginning and the end of the application to ensure the absolutely gas tightness. And if this joint is placed in the corner, as you see it here, is almost invisible for everyone. TPS material is a premium warm edge product with strong reduced condensation and very low U values. On this slide, we can see a direct comparison between installed windows with different insulating glass units, let's say, taken with a thermal imaging camera. On the left side, there are windows with insulating glass units with conventional aluminum spacers. On the right side, units with warm edge spacers like TPS. The infrared image shows on the right side of the building that the heat loss is significantly lower with insulating glass units with low E-coated glass plates, and so-called warm edge product as TPS. Then insulating glass units with uncoated glass plates and normal aluminum spacers, as it can be clearly seen in the image on the left side. This can be also illustrated numerically by significantly lower U values of the respective insulating glass unit. A further benefit of the spacer is that it's permanently flexible, as you see it here in this small animation. High elasticity and chemical bonding results in better mechanical performance during environmental changes, for example, heat and cold. Elongation of the edge area is spread over the width of the air space by TPS. Box spacer systems only has an amount of PIB available for the movement. Two chemical bonded joints replace the mechanical joint with standard PIB with reactive material. Therefore, such TPS units, for example, are also very used in trains, because in trains the pumping effect is extremely, especially when they passing through a tunnel. Among other things, IG units with TPS are known for their long life and gas tightness. If we compare it to conventional spacers, the total amount of boundaries is reduced by 50%. In traditional spacer construction, we have the contact between the glass and the butyl, butyl spacer, spacer butyl, and butyl glass. With TPS, there is a direct contact between TPS and glass. Therefore, the risk of potential gas loss is at least reduced by half. A further advantage is that TPS is possible to compensate tolerances, which means the wished total thickness of the IG unit during the press can be achieved. So it's possible to correct tolerances of glass panes and have still the same total package by adjusting the TPS spacer application width. This advantage is essential for window producers because the installation of the insulating glass unit in the window requires very narrow tolerances fields which cannot usually be maintained with conventional spacers due to the fixed thickness tolerances. This you can clearly here see. If you have not controlled this, then you have a blocking situation here and the IG unit cannot be installed in the window frame. With TPS, it can be compensated, the tolerance can be compensated by adjusting the TPS application, and this goes smoothly in the window frame. And by the way, this is only possible with TPS. As Gennadi mentioned before, everyone is talking about sustainability. If we finally compare the handling and amount of waste between foam spacers and TPS, it is also very impressive with regard to sustainability. On one side, we see that the handling is much more intensive, as Gennadi already mentioned, and on the other side, we see the waste overview. With TPS, you have mainly the drum, the plastic protective foil, the power belt, and the wooden pallet for the transport. With the elastic spacer, there are much more positions and much more waste is produced. And this is a further reason why TPS is much more sustainable compared to all other spacer types. Let's come to the outlook and the conclusion. The application field for TPS is very wide: residential, commercial, structural glazing, and so on. But beyond that, there is a further field which comes more, is the production of modern PIPV modules in the solar industry. The following video shows very clearly how solar glasses for functional glasses and with need an electrical contact to the outside can be encapsulated by TPS. First of all, there's the first application made and then the electrical contact will be taken out by a robot system. And with our multi-layer technology, we have then the possibility to encapsulate this electrical contact by a second application, which will taking place with a second applicator here. Now it's totally encapsulated, and this functional glass can then be, let's say, assembled together as an IG unit and installed as a PIB PV module in houses. The demand of PIB solar modules are increasing, and the first projects are already realized. Due to excellent properties of the material, TPS was also established in the solar industry. PIB facade with TPH modules, this was a development together with Fraunhofer Institute, easy to show a production process to manufacture wafer-based TPH modules. We have seen what kind of advantages and benefits there are with TPS technology. Not only the process, also the final product, gas tightness, warm edge spacer, flexible for heat-cold changes. In our perspective, with these presented properties, is definitely the best solution to meet the requirements for the future for the manufacturing of insulating glass production process. The increasing requirements in energy efficiency worldwide can be met. High insulating glass effect, maximum energy efficiency, long durability. Due to the excellent properties of the material TPS, it was also established in the solar industry. We hope we got with this presentation more interest about TPS, that TPS can play a more important role in the future for architects and for many, many window producers. Thank you very much from my side. Now we have the time to ask for some questions.